Hello guys, this is Hemant. Today I'm going to explain about a problem statement. So the problem statement is to reduce the power consumption of a solar tracking device which is inserted in the solar panel such that we can produce an effective solar power to the upcoming future. So the main description of our problem statement. So the main description of the problem statement is to reduce the power consumption of the trackers so we can choose an alternative way such as passive trackers. Now in the solar panels we are using active trackers. These active trackers uses some machines like motors or gears which produces or which consumes power and generates power. So nowadays, as the number of solar panels usages are using is more, the every megawatt is important for the upcoming future. So the main motto is to reduce their power consumption. So there are some passive solar trackers such as bimetallic steps which do not use any power but produces the effective result. But these are not as efficient or as accurate as the active. So the main motto to select this particular problem statement is to update or increase their efficiency and accuracy in terms of performance and the cost so that in the upcoming future we can increase the solar power generation. So actually a solar tracker is a device which helps the solar panel to align around the sun according to the sun rays so that we can produce the effective power generation, solar power generation. So, however, these devices consume solar trackers consume the power. This can reduce the overall performance and the efficiency of the solar panel system. So, the another method or alternative method is to use passive trackers, which are not wide range in market usage, but we can increase their efficiency and accuracy. And I have a very strong hope that in the upcoming future we can increase their efficiency and increase the solar power generation. So this is a sample example of a solar tracker in a solar panel which helps the panel to move around the sun rays in both the axis like x and y so that it can generate the solar power. So next, to the particular problem statement, who are the customers and why are the customers to the particular problem statement? So the main customers of this particular problem are electric companies and corporations and agricultural productions. Here agricultural productions means greenhouse farming and some etc. so on. So what are the main motivations of them to be the customers of this particular problem statement? Environment awareness and government policies which are encouraging the people or citizens to move around to keep in step around the solar panels so that they can reduce their electricity bills compared to the solar. And then some technical advancements such as using this active trackers nowadays increases the solar trackers but solar power. So yeah, using these solar trackers increases the power consumption of the solar panels, which can help the households or any companies to increase their power and decrease their electricity bills compared to the other sources. And then, according to the customer perspective, how is our problem reflecting to them? So currently, solar panels with the solar trackers that consume power may add an extra overall cost to the customer for installation and the maintenance purposes. So as the solar trackers consume power, they require some additional care or additional maintenance and some repairs, which is time consuming and extra budget for the customer. And which by extra modifying or reinstalling the solar trackers will reduce the overall efficiency and the performance of the solar panel system. So nowadays, customers who are using the solar panels, they are connecting electrical grids to sell any excess electricity that generate back to their utility company, such that it can be a backup source for them, and which is also a very efficient way for the companies who install the solar panels to repair or maintain them. So solar panels performance can be affected by the weather conditions also, such as rain, thunders, and etc. So, as we discussed before, that backup energy source should be needed from a particular customer in a household or a company, so that whenever these solar panels are not an efficient way to work, they can use them. So here in this picture, we can see a solar panel with a solar tracker and a control system. Here, the solar tracker helps the solar panel to move all around the sun rays to generate the power, and this is controlled by the control system. So next, so this is a sample graph of a cumulative growth of the solar applications all over the world. So it is a sample graph from 2017 year to 2022. The left indicates the production of a megabyte of solar power in megabytes, and right indicates the population of the usages of solar energy. So here some of the small minor parts are solar house sources, industrial purpose mini grids, and their electricity access from the solar house sources. So here mainly solar house sources are the electrical companies which are selling the electricity to the companies, households, and so on. So in the next slide, we're going to discuss about some different perspectives, which is continued with by my friend.
Hi, I am Lokesh. I am here to explain you about the deeper understanding of the problem in different perspectives. The problem context of solar trackers that consumer power is complex and multi-phase, with the different perspectives and considerations to take into account. Here are some deeper understandings of the problem context from different perspectives. So, first of all, let's get about some perspectives. Let us start with technical perspective. From technical perspective, the problem with the solar trackers that consume power is that they add an extra layer of an complexity to a solar panel system. Solar trackers that consume power require additional electronics, sensors, and motors to operate, which can increase the risk of system failure or maintenance issue. Additionally, power-hungry solar trackers may not be able to operate efficiently in certain environmental conditions, such as extreme heat or cold. As the complexity increases, the number of elements that contribute for a function of the solar tracker increases. As a result, the power consumption of the entire solar tracker increases, which result in a high cost and which can be affordable for normal customers. Okay, now from an economic perspective, the problem with the solar trackers that consume power is that they can add a significant cost to a solar panel system. Customers who are looking to reduce their energy cost and generate a return on their investment may be hesitant to invest in solar trackers that consume power, as they may not provide a significant enough increase in energy output to justify the additional expense. Most of the customers for the solar panels are like farmers and some small industries which cannot afford a solar trackers because of their high cost and less output or less efficiency. So, from a geographical perspective, the problem with the solar trackers that consume power is that they may not be suitable for all locations or environments. Solar trackers that consume power may be more prone to damage or failure in extreme weather conditions such as high winds and high snow. Additionally, solar trackers that require regular maintenance or calibration may be more difficult to manage in a remote or hard to reach locations. Customers who are considering solar trackers may need to carefully look the local environmental conditions and the logistical challenges associated with the installations and maintenance. So, in hilly regions, we may not able to install solar panels, which may cause some damage to solar trackers, or it is not a specific area for region for installation of solar trackers. Now we'll go to the innovation perspective. From innovation perspective, the problem with the solar trackers that consume power is that there may be opportunities to develop a new and more efficient solar tracking technologies. Researchers and innovators are exploring a new approaches to solar tracking that minimizes energy consumption and improve accuracy, such as using smart materials, optical sensors, and artificial intelligence. As these technologies become more mature, they may offer customers a more compelling alternative to a traditional solar trackers that consume power. Now we are working on a present situation like this. Solar trackers which which uses less power or no power consumption. So we are now working on present this condition. So thank you thank you for listening to our presentation.